Alright, today we're going to go over the post-test study guide, part 1. It's going to be problems numbers 1 through 16. I don't believe there's going to be any mistakes on purpose, but you never know, I could make one by accident. Now, there's a hint page that goes with this. It's super important that you get used to using this hint page. This hint page is going to be what makes it so we can pretty much do everything we need to do in case you get lost. So, I have decided that I could tell you what numbers are going to go with what. So like numbers 1, 2, 3, and 4 will be using PEMDAS backwards. 3 and 4 will also be using this absolute value for equations. 5 and 6. 5 will be using substitution. 6 will be using elimination. 7 and 8 will be using factoring, which means also be using the GPS. You could use the quadratic formula for 9 and 11, but you also could use completing the square. So you could be using the quadratic formula. Now remember, the GPS is the GPS you can use for 7 and 8. And any other one that's factorable. We will use PEMDAS backwards for 10, 12, 13, 14. 15 and 16 will also use the GPS. So you also could be using you could be using the complete the square for 9 and 11, or so that's just an option too. And whenever you're using completing the square or anything like with quadratic formula, you're probably going to have to use simplifying radicals and radical properties, so you have to remember those too. Alright, so number 1, we have 4n minus 8 is less than negative 12n plus 8. Now we're going to use PEMDAS backwards. Now remember, PEMDAS backwards for one variable. So the first thing I'm going to do is I'm going to move the 12n's over. So I'm going to add 12n to both sides. It's going to give me 16n minus 8 is less than 8. Now, I'm going to add 8 to both sides because I want to get rid of the subtraction. I end up with 16n is less than 16. Well, there is no addition, there's no division, there's multiplication. How do I get multiplication? Well, I divide both sides by 16. So I end up with n is less than 1. Now remember, you have to put a number line there. So the number line below number 1 is the number line that goes for number 1. So I'm going to put 1 on my number line. I put 0. And it's an open circle. It's an open circle because right here, there is no bar at the bottom. That's why it's open, because it can't actually equal to 1. So I'm going to shade to the right. So it's all the numbers less than 1. And that's it for 1. Alright, so number 2, very similar. We have 4x plus 6 is less than negative 22, or 5x plus 1 is greater than 26. Now, I'm going to basically do both these problems separately and then put them on the same number line. So I am going to use PEMDAS backwards again. So for the first part, for the left side, there's addition, so I get rid of it by subtraction, so I have minus 6 from both sides. I end up with 4x is less than negative 28. I also have to divide it both sides by 4. So I get x is less than negative 7. I did the same exact thing for the right side. I minus 1 from both sides. I get 5x is greater than 25. Now I divide both sides by 5. x is greater than 5. Now I'm not done yet, so I got to make a number line. I'm going to put negative 7 on the number line. I'm going to put 5 on the number line. They both are going to be open circles. Now, it's less than negative 7. So I go to the left, put an arrow. It's greater than 5, so I go to the right, put an arrow. And that's it for 2. Alright, number 3, the absolute value of 2/3 x minus 4 equals 6. So remember, absolute value, the 2 bars, means write it twice. It says you write it once, don't change a thing. You write it twice, and the only thing you change is after the equal sign, you make it the opposite. Alright, so I'm going to write it twice. Once, I don't change a thing. 2/3 x minus 4 equals 6. The second time I write it, 2/3 x minus 4. See how I did not change the minus 4? Equals negative 6. That's the change. Now I'm going to use penmanship backwards. I'm going to add 4 to both sides. I get 2/3 x equals 10. I'm going to multiply both sides by 3/2. That's the reciprocal. You could divide both sides by 2/3. Either way, you're going to get x equals 15. Now you do the same thing with this one. Now let's say you don't like fractions. You could multiply everything by 3 to start. So you don't have to do that, but you could. So then you end up with 2x minus 12 equals negative 18. Now I'm going to add 12 to both sides. So I get 2x equals negative 6. Divide by 2 on both sides. I get x equals negative 3. So with this one, you get 2 answers. The reason there's not a line underneath number 3 is because it's an equal sign, so you don't need to put it on a number line. And that's it for 3. Alright, number 4. I have the absolute value of 14 minus x is less than or equal to 28. Now once again, remember, the absolute value sign means you're going to write it twice. Now, the first time you write it, you don't change a thing. So I write 14 minus x is less than 28. The second time you write it, you make it greater than. You have to flip this sign because you're going to flip that sign. Remember, that's the rule with inequalities. When you divide by a negative 1, you flip the inequality. So I divided to make that show up. So that's how come it flipped. So that's a big deal. Don't forget to flip that. Okay? Now, I'm just going to get rid of the 14 by subtracting 14 on both sides. I get negative x is less than or equal to, not 28, 14. Now I'm going to divide both sides by negative 1. Now the rule is, since I divided both sides by negative 1, that less than or equal to becomes greater than or equal to. So I end up with x is greater than or equal to negative 14. I do the same thing. I minus 14 from both sides. I get negative x is greater than or equal to negative 42. I divide both sides by negative 1. Now remember, when you divide both sides by negative 1, that greater than or equal to, even though I flipped the beginning, I am going to flip it again, so it's less than or equal to. So I have x is less than or equal to positive 42. So now I'm going to make my number line. I put 42 on this side. It is a closed circle because there's a bar right there. I put negative 14 on this side. Also a closed circle. I always like to put 0 on there. And now look, I'm going to shade. It's greater than 14, so I'm going to shade this way. It's less than 42, so I'm going to shade that way. So it's just in between. And that's it for 4. Alright, number 5. Number 5, I'm going to use substitution because there's already a letter by itself. So that means I'm going to put y plus 3 in wherever I see an x. So basically, I'm going to rewrite the top equation. So I'm going to rewrite the top one. 2y minus 8. Instead of x, I'm going to put y plus 3. Alright? Equals negative 18. So that's the substitution part. So step 1's done. So I substitute the expression into the other equation. I have to distribute. I get 2y minus 8y minus 24 equals negative 18. I'm going to combine my like terms. I'm going to get minus 6y minus 24 equals negative 18. I'm going to add 24 to both sides. So I have negative 6y equals positive 6. So y equals negative 1 when I divide both sides by 6. Now I take that negative 1 and I'm going to plug it into the original. So I'm going to say x equals negative 1 plus 3. So x equals 2. I have an x, I have a y. I write my answer as an ordered pair 2, negative 1. So that's your answer. That's it for 5. Alright, number 6, I'm going to use elimination because they're already lined up, so step 1's done. Step 2 is also done because I already have matching. The x's already have the same number but opposite signs. So I combine those. I'm going to add vertically, which means those cancel out. I end up with 4y equals 12. Really easy to solve. So now I just divide both sides by 4. I get y equals 3. It doesn't matter where you put y in. You can put it at the top or the bottom. You just got to put it into one form. One of them, so I'll do the top. 6x minus 10 times 3 equals 34. So I get 6x minus 30 equals 34. I add 30 to both sides. I get 6x equals 64. So x is going to be equal to 64 over 6. I'm probably going to write it as 32 over 3, but you could also write it as 10 and 2/3. Either way is fine with me. Remember, the last thing you got to do is write as an ordered pair. So 10 and 2/3, 3, and that's it for 6. All right, number 7, I have x squared minus 3x equals 10. Remember, it must equal 0 to factor. So the first thing I'm going to do is I'm minus 10 from both sides. I'm going to get a problem that says x squared minus 3x minus 10 equals 0. Now, there is nothing in common, so if I'm using my GPS, there's nothing in common. So I'm going to break down the factors of the first term. How do I get x squared? X and x. How do I get negative 10? Well, I have negative 1 and 10, or negative 2 and 5. Negative 2 and 5 almost add up to 3. So I want them to be negative 3, so I make it positive 2 and negative 5. So this is going to factor into x plus 2, x minus 5. Remember, since it equals 0, I'm allowed to say x plus 2 equals 0, x minus 5 equals 0. Subtract 2 from both sides, x is equal to negative 2. Add 5 to both sides, x is equal to 5. 2 answers. Because they are nice answers, it's factorable. And that's it for 7. So number 8, it's already equal to 0. It equals 0. Now I'm going to have to factor. So how do I get x squared? X and x. How do I get negative 54? Well, 1 and negative 54, that doesn't help me. 2 and negative 27 doesn't help me. 3 and negative 18 doesn't help me. 4 doesn't work. 5 doesn't work. 6 and negative 9. Now that adds up to give you negative 3, so I want to do negative 6 and positive 9. So I'm going to write it as x minus 6, x plus 9 equals 0. Remember, since it equals 0, I get to say this guy equals 0, or x plus 9 equals 0. I add 6 to both sides on the left equation. I end up with x equals 6 as my first answer. I subtract 9 from both sides on the right side. I get x equals negative 9. 2 answers for number 8. Since they're nice answers, it turned out it was factorable. Alright, so number 9 can be solved using the quadratic formula, or it can be solved using completing the square. Complete the square is the most recent thing. We really didn't talk that much about the quadratic formula, so it doesn't matter which way you do it. If you're going to use quadratic formula, it's got to equal 0, and then a is 1, b is 8, c is 25. And then you plug it into x equals the opposite of b plus or minus b squared minus 4ac all over 2a. So that's an option. Okay, you can do that. Right, you don't have to do that. I'm not going to do that for this one because b is even. Since b is even and x squared is already 1, I'm going to use completing the square. So I'm going to use the completing the square method. Alright? So I'm going to complete the square. So if you check your end page, the first thing you should do is you have to make the first thing you should do when you do your end page, when you look at the end page, is it says make x squared and x all alone. So I have to minus 25 from both sides. So then I end up with x squared plus 8x equals negative 25. Now I have to do my b over 2, so I'm going to find a c. So I'm going to say c equals b over 2 squared. So c is equal to 8 over 2, which is 4 squared, which is 16. So I'm going to add this 16 to both sides. I'm going to put plus 16 here, plus 16 here. So the left side becomes x plus 4 squared. The right side becomes negative 9. Now I get to use penultimate backwards, so I square root both sides. I get x plus 4 equals plus or minus. That negative sign right here turns into I. The square root of 9 is 3. Last bit is I get to subtract 4 from both sides, so my best answer is negative 4 plus or minus 3i. Now remember, that can be written twice, which is why the multiple choice answers have two answers, the negative 4 plus 3i and negative 4 minus 3i. Now, number 10, you could use quadratic formula if you really wanted to. I would not recommend doing that. Because there's only one variable, I'm going to use penultimate backwards. There is no subtraction. There's addition, which is why I'm minus 300 from both sides. So I get 10 x squared equals negative 300. Now, their addition's gone. There's no division. There's multiplication. That's why I divide both sides by 10. So I end up with x squared equals negative 30. Well, now I'm going to square root both sides. So I'm going to get x equals plus or minus. The negative inside the radical turns into I. 30 is not perfect, and there are no perfect factors for 30. So that's it. You're done. That's it for 10. All right, number 11, you can use the quadratic formula, but I am going to complete the square. Now remember, if you want to complete the square, you must have 1x squared. So the first thing I'm going to do, and even if I was going to use the quadratic formula, I'd probably do this, because then everything gets a little bit smaller, everything gets a little bit easier. So I'm going to divide everything by 8, and I'm going to have x squared plus 6x equals negative 3. Now I have x squared plus 6x all alone on one side, and it's 1x squared, so now I get to do c equals 6 over 2 squared. So that's 3 squared, which is 9. I'm going to add 9 to both sides. Now the left side becomes x plus 3 squared. The right side becomes 6. So now I'm going to use penultimate backwards. I'm going to square root both sides. So I end up with x plus 3 equals plus or minus. Remember, whenever you square root both sides, plus or minus shows up. And now I'm going to subtract 3 from both sides. So my best answer is going to be negative 3 plus or minus radical 6. And that's it for 11. All right, number 12. Once again, if you want to make it equal 0 and use the quadratic formula, you're more than welcome to. I would recommend using penultimate backwards because there's only one variable. So there is no subtraction. There's addition, which is why I minus 130 from both sides. So then I end up with 6x squared equals negative 144. Well, addition's gone. There's no division. There's multiplication, which is why I divide both sides by 6. So I end up with x squared equals negative 24. Now, I'm going to get rid of the exponent by square rooting both sides. So I get x equals plus or minus. That negative turns into I. Now, 24 is not perfect, but 4 goes into it 6 times. So this 4 is going to turn into 2. So I have x equals plus or minus 2i radical 6. That's the best answer, and that's it for 12. All right, number 13, I'd love to use penultimate backward eventually, but I can't until I get rid of those parentheses. So before I try to use penultimate backwards, I'm going to FOIL the left side. So I'm going to go FOIL. So I do the first part of FOIL. 9 times 9 is 81. X times x is x squared. So 9x times 9x is 81x squared. The outside, I do 9x times radical 2. Remember, 9x is not in jail. Radical 2 is in jail. The inside, I have a minus 9x radical 2. Remember, 9x and 2 cannot be multiplied because one is out of jail, one is in jail. But radical 2 and radical 2, those two can be multiplied together to get radical 4 because they're both inside the radical. Now I'm going to combine my like terms. Those cancel in the middle. So I end up with 81x squared. Remember, square root of 4 is 2. Now it's just penmanship backwards. There is a subtraction. That's why I'm going to add 2 to both sides. So I end up with 81x squared equals 161. Now I'm going to divide both sides by 2 or by 81 because that's how I get rid of the multiplication. And guys, even though it's a messy fraction, just leave it as a fraction. I'm just going to leave it. I'm just going to leave it as 161 all over 81. I'm not going to try to simplify it or anything like that because I still have work to do. So I'm going to square root both sides. I end up with x equals plus or minus square root of 161 all over the square root of 81. This one actually works out really nicely because 81 is perfect. So the best answer is going to be plus or minus the square root of 161 all over 9. And if there was a perfect that went to 161, I would look for it. But I don't think there is one. So that's it for 13. All right, 14 a lot of people struggle with because they just don't understand the concept right away. But beforehand, whenever we had a square, we would use the radical to get rid of it. That means that the square will get rid of the radical. So to make the radical disappear, I square both sides. Now, the little 2 and the radical cancel out. The little 2 doesn't affect the 3x and the 12. So now I'm just going to do penmanship backwards. All right, I got to get rid of the addition, so I minus 12 from both sides. So I end up with 3x equals 24. Divide both sides by 3. I get x equals 8. And that's it. 15 and 16. Factor. Do not solve. Right? There is no equal sign. Your answer is going to be sets of parentheses. Right? So there's 3 terms here. So we're using the GPS. So the GPS, okay, there's nothing in common. The first term factors are x and x. How do I get 63? Well, it could be 1 is 63, which isn't going to help me. 2 isn't going to work. 3 and 21 could work. 4 doesn't work. 5 doesn't work. 6 works. 7 and 9. And 9 and 7 work because they have to be 16. The only thing is you have to make them subtraction. And that's your answer, just the sets of parentheses. All right, 20. The first thing we're going to do is we're going to use our GPS. And the first thing I noticed that both of these are divisible by 9. Now, you cannot make an equal sign and just divide both sides by 9. I saw a bunch of mistakes with that. I just take the 9 outside the parentheses, and then I divide on the inside. Now, I'm going to use the GPS for what's inside the parentheses. It's got 2 terms. They are both perfect. So we have this shortcut that says if they're both perfect and there's a subtraction sign in the middle, you get to add the square roots and subtract the square roots. So that's x and x. That's 3 and 3. So it becomes x plus 3, x minus 3. Now don't forget that 9 that was there. So that's your best answer right there. And I don't know why I wrote 20 here. That was 16. And that's it. 1 through 16. Done.